Alright, what's grooving everyone? Welcome back to Bo Maths. Last time we talked about how multiplication stretches the number line, and we saw that the distances between kind of ticks on the number line that increased, which effectively stretched the number line, and we saw by doing that, that allowed us to multiply any number on the number line. So now we're just going to get more comfortable with the concepts introduced in that video and do some problems here with some interesting applications in number 2, which we'll get to in a second. So number 1, solve by stretching the number line. So for this one we have 0.1 times 4, 0.2 times 4, and negative 0.2 times 4. So all these are multiplied by 4, which means we can just solve this using one number line stretch. And because it's with decimals, we might want to use a number line that looks something like this, where, as you can see here, I've labeled the number line with each tick is worth kind of 0.1 instead of being worth 1 like we saw with the number lines that we tend to work with. But again, because this is just a representation of numbers, we can have it as zoomed in or as zoomed out as we want to, and as long as just each tick from one to the next is the same distance, then we can label this however we want. So in this case, I'm labeling them with 0.1s just because we're dealing with smaller values here. All right, and to stretch the number line, we're going to need another number line, so I'm going to draw one here. So we have our number line here that we're going to stretch, and again we can imagine there being more numbers, but I'm just going to keep focused on this region right now because we're going to be multiplying this by 4. So these are going to be spreading out quite widely, right? It wants us to multiply them all by 4. So multiplying it by 4, we keep our 0 fixed, and we increase the distance between ticks to be 4 times bigger. All right, so it's like that. And then to get 4 times bigger, this 0.3 is actually going to be going off the page. It's going to line up with 1.2 since 0.3 times 4 is 1.2. And we'll also stretch these out to be 4 times as long. All right. So again, this number line goes on infinitely. So 0.3 and negative 0.3 do line up with something. It's too big for me to represent on the page here. So it asks us to look at part A, which is 0.1 times 4. All right, well, where does 0.1 line up? 0.1 lines up with 0.4 because once we've multiplied it by 4, stretch all the distances out by a factor of 4, it's going to line up with what it is multiplied by 4. So that means 0.1 times 0.4 has to, or sorry, 0.1 times 4 has to equal 0.4. All right, and then part B, 0.2 times 4. Well, 0.2 is over here, and that lines up with 0.8. So we get that 0.2 times 4. That equals 0.8, right? I stretch the number line by a factor of 4, and the 0.2 lines up with 0.8 here, which means that 0.2 times 4 equals 0.8. And lastly, we have negative 0.2 times 4. So negative 0.2 times 4. All right, so once again, we look to see where does negative 0.2 in this case, which is right here, where does that line up? Well, after stretching it, it lines up with negative 0.8, which means that negative 0.2 times 4 has to equal negative 0.8. All right, so because all of these are multiplied by 4, doing one operation to the number line allows us to figure out what any number times 4 equals. All right, let's talk about black holes. So in outer space, right, there's when a star dies, so you got outer space over here, and you have a bunch of stars in that space. But eventually, a star, it kind of like collapses under its weight because stars kind of get bigger and bigger over time. So eventually, when this star dies, sometimes it becomes what's called a black hole, right? And so a black hole is this thing that goes throughout space and it sucks up everything in its path. And there's a lot of different theories about kind of what exactly black holes look like. It's an extremely complicated topic. I myself don't even know all of the science behind it. But one of the theories is that basically what a black hole does is it sucks stuff into it, right? So there's light and matter and planets and stuff all around. It kind of sucks everything into it, and nothing can escape it. But the stuff that gets sucked into it, it all gets compressed down to a single point. So one theory is that there's like an infinitely small point inside the black hole that all the matter just gets shoved down into. And so that's what this question is saying. One theory on black holes is that at a center of the black hole, there's a singularity in which all matter that gets sucked into it gets compressed down into. So this point at the very middle of the black hole, that's like the singularity. And all the matter in here, it gets all the matter around it gets sucked into the black hole, and eventually, almost like a whirlpool, right, gets sucked right into the very middle. And so I'm saying, can we kind of gain some insight into the process using the number line? Well, if you recall from last video, we saw that there was one thing that kind of compressed everything down. And do you remember what that was? Well, multiplying by a number, that basically changes what the distance between the ticks were. And we saw that when we multiply by 0, that makes all the distances go to 0, namely they're all on the same point. So everything kind of gets collapsed down to 0. So we can kind of think of a black hole as like this multiplying by 0 in some sense, where it's going through space. And if we think of space as kind of like our number line, it's like collapsing everything down. It's getting sucked into it, and it gets all pushed down into this singularity of the black hole. Of course, it's a lot more complicated than that, but that's just kind of one perspective that we can use to kind of gain some insight into what's going on here. So I hope you found that example kind of interesting, and let's move on to number 3. All right, so we're going to go on to question 3 here. And if I sound a little bit different, that's because I wasn't happy with my first explanation of this, so I'm just adding this on afterwards. But that's all right. So this says I stretched the number line by 2 and then stretched it again by 3. How can I express the overall change to the number line as a single operation on it? So basically we're doing two things to the number line. We're stretching it once by 2 and we're stretching it again by 3, but we want to express this as a single operation to show the whole change. So for this, got a number line, and I've labeled this one maybe a little bit different than our standard one where I have 0 over here, but the reason I'm doing that is I'm going to be getting some bigger numbers because I'm stretching it by 2 and then by 3, so that's a lot of stretching. So to kind of represent some of those bigger numbers, I'm starting at 0 and getting to some larger values than I would have been doing otherwise. All right, so let's draw in a number line here. And you can imagine all of these continuing on, 4, 5, 6, and so on, but we're going to be stretching it a lot, so all of those are going to go off the page. So I'm going to multiply this by 2, which means that all of these ticks, which have this distance of 1 from each other, are now going to double in their distance. All right, so 3 lines up with 6, since 3 times 2 is 6. 2 lines up with 4, since 2 times 2 is 4, and so on. So we've multiplied this number line by 2 by stretching it out to be 2 times longer in terms of the tick distance. And now we're going to do it again, where we're going to be stretching it out by 3. So I'm going to draw in another number line. All right, so I have 0, 1, 2, 3. Now, should I line them up with this number line or with the first one? Well, I'm going to be lining it up with this second one here because what the question asks us to do is stretch it by 2 and then stretch it by 3. So we're going to be stretching the already stretched one by 3. So we have to start with how it is like this. All right, so I'm going to multiply it by 3. So all of these distances, not these ones, but these distances are going to become 3 times bigger. So it's going to look something like that about. All right, so these are all around the same distance, and it's 3 times bigger than it was before, right? It's there, and now it's 3 times bigger. We see 1 lines up with 3, since 1 times 3 is 3. If we were to have more, this would be maybe 4, 5, 6, so it looks like 2 would line up with 6, since 2 times 3 is 6, and we would expect 3 to line up with wherever 9 is, right? But since we want to do this relative to the first one, right, we want to see, okay, what can we multiply this first one by in order to get to this final number line here? What we need to do is we need to compare where we ended up after these two different stretches to the original line. So we see that 1 lines up with 6, 2 lines up with 12, and 3 lines up with 18. So what could we stretch this original number line by in order to get here? Well, 1 times what is 6? 2 times what is 12? 3 times what is 18? It's 6, right? 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18. So it would appear that we've stretched this number line here, going from the first to the last, by a factor of 6. And we can also deduce that by just looking at the two different stretches that we did in the intermediate processes, where from the first to the second we multiplied by 2, and from the second to the third we multiplied by 3. What's 2 times 3? It's 6, right? So overall, this transformation here, when we multiply it out, we get the transformation of 6. So we've actually multiplied this whole number line here by 6. All right, moving on to number 4. What can I multiply the number line by such that I don't change it at all? So if you recall from previous videos, we saw that adding 0 to the number line and subtracting 0 from the number line, that didn't change the number line at all, right? Because that basically shifted it by nothing. But now I'm asking, okay, what can we multiply the number line by such that it doesn't change it? Well, we know it can't be multiplying it by 0 because we saw that that collapses everything down. So that certainly changes what the number line looks like. But what can we multiply something by such that it doesn't change anything about the number line? If we multiply the number line by 1, right? All right, so if I want this number line to be the same as this number line, if I multiply everything by 1, well, that's not going to change anything, right? Because already the distances are kind of 1 unit, and we're saying, okay, we want those distances to basically just be the same 1 unit as before, right? So we haven't changed the distances, thus the number line stays completely still, and we see it works out. What's 1 times 1? Well, it's 1. What's 2 times 1? It's 2. What's negative 2 times 1? It's negative 2, right? So we know that multiplying by 1 is the same thing as just the number itself, right? Any number times 1 equals itself, because we're basically just taking one group of that number. And if you have one group of that number, it's just the number, right? If I know that a group is like 3 circles and I'm taking one group, then I know that I have 3 circles, right? I'm not needing to add anything more to that. So similarly, when multiplying the number line by 1, we're not changing the distances between anything, so it stays the exact same. All right, and then number 5 says, try to explain using number line stretching why multiplying a positive by a negative is a negative. So this is something that hopefully you recall learning at some point, that a positive number times a negative number is a negative. For example, 3 times negative 2. Well, we know that 3 times 2 is 6, but because we have a positive and a negative, it becomes negative 6. This is what you've learned at some point in school. But now what I want to do is I want to kind of give a justification for why it's like that using number line stretching. Okay, so the key here is that we've been multiplying by positive numbers the whole time. And we don't need to change that when we're considering a positive times a negative. If I have negative 1 times 4, I can multiply the number line by positive 4. If I have 5 times negative 2, I can multiply the number line by positive 5. If I have 7 times negative 1, I can multiply the number line by 7, right? So because it's always a negative with a positive, because that's just what the question's talking about, we can always choose the positive to be what we multiply the number line by. So we don't have to worry about multiplying the number line by a negative number. We will do that in a future video because that's also important to do, but we're going to just talk about multiplying by a positive number right now. And so what we do is if we multiply the number line by a positive, we know that's going to stretch it in some way, right? So it doesn't really matter much how things get stretched. Maybe I multiply it by 2 and it goes to a configuration like this. But ultimately, because our distances are just expanding and 0 is fixed, all these negatives still stay to the left of 0, which means they're always going to be lining up with a negative still. If I were to expand everything to be multiplied by 4, let's say. So I've stretched the number line out. These 3's will line up with 12 and negative 12. Again, 0 stays fixed, so everything to the left of 0, namely all the negatives, even though we've expanded the number line, they still remain to the left of 0, so they're going to be lining up with things on the left of 0. So we see that multiplying the number line by a positive doesn't change the order of things. It keeps the negatives negatives and it keeps the positives positive. All it does is it stretches things, but since 0 is staying the same, all the negatives times this positive will remain negative. And so this is kind of one perspective that we can take on explaining why a positive times a negative is still a negative number. I hope you found that video useful. Next time we're going to be looking at dividing the number line, which has some similarities to this, so I encourage you to think about what that might look like before you watch the next one. Well, as always, thanks for watching, have a good one, stay groovy, and I'll see you in the next video.